Good evening, everybody, and welcome back to this session of our Viva class. Today, we are going to do VOR, that is on your page number 36 of your Viva book. Please look at your Viva book, page number 36, then we'll look at VOR today. Now, as you look at this page number 36 in VOR, what you see is the full form of VOR. See, this is the short form, VOR. The full form of VOR is V for very high frequency, VHF. V for VHF. O for omnidirectional, O for omnidirectional, and R for radio range. Now, this is the full form of VOR, VHF, omnidirectional radio range. We know a lot of things when you look at this sentence. VHF, VHF means very high frequency. VHF means very high frequency. That means this navigational aid, this is a navigational aid. This is a navigational aid. VOR is a navigational aid. This navigational aid is working on VHF. VHF, that means very high frequency. It's working in the VHF band. And it is omnidirectional. It is omnidirectional, that is multi-directional, or rather in all directions, all the 360 directions. That means whatever navigation it is offering or it is giving, it is in all the 360 possible directions. VOR is transmitting in all the 360 directions, but on the VHF band. Radio range, that means it is transmitting radio signals which has a specific range. Of course, when we go more deep into VOR, we will know what is the range of VOR also. Presently, you must only know that it is working on the VHF band, and it's omnidirectional in all 360 directions. The transmission takes place of VOR. It's a navigational aid, and it has got a radio range. It has got its own range. All right, one thing. Secondly, just to give you a base or to start with, first we must know on what frequencies and which VHF frequency it normally works. Okay, so as per your book and as per the guidelines of ICAO, we say VOR operates from 108 to 117 decimal 975. 108. What is this 108? 108 megahertz, 108 megahertz. This is the lower side band. From 108 it starts. The side band, the band width starts from 108. That is 108 megahertz. It starts to 117 decimal 975. 117 decimal 975. Or to be very precise, we can say 118 megahertz. 118 megahertz. VOR works up to 118 megahertz. All right. If you want to be very, very exact, then it is 117 decimal 975. But if we round it off, then it is 118 decimal 975. We take it as 8. We take the 7 as 8. Okay. So 118. VOR operates in 108 to 117 decimal 975 megahertz. But the frequency allocation of VOR is 108 to 117 decimal 975, 108 to 112, 108 to 112. It's an ILS frequency band. Actually, this is also used by ILS, that is Instrument Landing System. Instrument Landing System also is an aid, but not a navigational aid. It's a landing aid. It's used for landing. It's not used for navigation. But VOR is not used for landing, for navigation. But this frequency band, which is used by VOR from 108 to 117, also contains 112 also. It is up to 117, so it must definitely contain 112 also. Now you will be wondering how ILS also and VOR both work on the same band. Now we'll discuss this another 2 minutes. Okay. But ICAO allows the sharing with VOR. But the ICAO has allowed the sharing of this band, which is primarily 108 to 112 is used by ILS. But this is also shared by VOR. It is not fully subscribed. That the VOR uses frequency on even first decimals. Okay, even first decimals. Out of this 108 to 112, from 108 to 112 up to this 4, you can say a bandwidth of 4 megahertz. In the bandwidth of this 4 megahertz, VOR is on even first decimal, even decimals. It is the frequency allocation will be on even numbers. From 108 it will start and even up to 112. And the ILS will use odd first decimals, odd 108 decimal 10, 108 decimal 15. Of course, 108 decimal 20, 108 decimal 25. That way, that is the even, and ILS will use odd first decimal, odd first decimal. The decimal spacing will be odd and even. so that they or decimals. Okay. Then after the 112 to 117 decimal line, VOR band. But before 108 to 112, it is shared with ILS. That actually we go magnetic north here, magnetic north, and from magnetic north we are starting. That is magnetic north. I told you is 0, 0, 0 degrees or 360 degrees, and when you go clockwise, when you go to the right or clockwise, 0 degrees, 030 degrees, 040, each this spacing is of 10 degrees, spacing is of 10 degrees each. So we have divided this into 360 degrees, right? This diagram is divided into 360 degrees. So when we are talking about a VOR station, whenever we construct a VOR station, now we'll talk about VOR station in two ways. One thing is the construction of the VOR station on the ground, and second one is the receiver in the aircraft, which will receive the signals of this installation on the ground. So actually VOR is a transmitter, which is based on the ground. And we have a VOR receiver in the aircraft, which receives this ground-based transmission to give you the navigational, we can say, displays on in your aircraft. You will have a navigational display. But on the ground, when you have this VOR station, it has to be calibrated into 360 degrees. I told you it is transmitting in 360 direction. So the calibration of this VOR will be in 360 degrees, something like this. So that means the first thing which we do when we construct a VOR station on the ground, whether any place when we are going to planning to install a VOR system, what we first do is we ascertain the magnetic north of that VOR. Suppose we decided that we are going to construct a VOR in, suppose, Mumbai. All right. So in Mumbai, first of all thing, whenever we are going to construct the VOR, we first of all ascertain the magnetic north of that VOR. What will be the magnetic north of that VOR? First, we find out the magnetic north of that VOR, and from that magnetic north, we calibrate that VOR. We calibrate that VOR into 360 degrees or 360 degrees, see, 10, 20, 30. Each calibration is of 1 degree, 001, 002, 003, 004, so on up to 360. Once this calibration is done, now this calibration is done. When this calibration is done, actually what happens after the calibration is done, we'll now fix we'll fix a antenna. We'll fix an antenna in the magnetic north direction. We'll fix one antenna, that is a vertical antenna, or we can say vertical signal antenna, that will be known as the reference phase antenna. That will be known as the reference phase antenna. So we calibrated the VOR in 360 degrees. After that, when we found out the magnetic north, we fixed the antenna facing that magnetic north. That antenna which we are fixing now is facing that magnetic north on the VOR station. That is on the construction of the VOR. VOR station actually is an installation which is installed on top of a room. On top of a room. In the room, of course, we'll have the equipment, and on top of the room, we'll have the equipment, the installation equipment. I will show it to you with the help of a diagram just now. Actually the VOR construction looks like this. See, this is that vertical antenna. We calibrated this into 360 degrees, and in 360 degrees, then we found out this is the magnetic north. So towards the magnetic north, this antenna is pointing. Towards the magnetic north, this antenna is pointing. Now then you must be wondering, only the magnetic north is pointing towards the antenna is pointing towards the magnetic north. What about these other structures? What are these structures? Actually, all these structures are also antennas. All these structures are also antenna. Each antenna difference is 1 degree. Each antenna difference is 1 degree. It is starting from magnetic north. So first antenna will be, the first antenna will be, see, you can see this antenna. Now, when you look very carefully, this actually looks like a, something like a dish TV, dish of your home. Suppose you have a dish TV at home, you have a concave dish that is installed on the terrace. Okay, you get the signal. It is something like this. Only thing, it is not inclined up, it is inclined upwards toward the sky. So this is the concave shaped disc. In that disc, we place this 360 antennas, and in the center of that dish, we place one antenna. Even at home, if you observe in your dish, TV antenna, circular dish, you will see there is one vertical elongation coming out like that. That is actually the sense antenna or vertical antenna. Here also, this is supposed to be the sense antenna or vertical antenna, which is pointing towards the magnetic north of the VOR. Pointing, it is like in the diagram, it may look straight. Actually, it is not straight. It is slightly tilted, slightly tilted towards the north direction. And all these antennas, all these other three antennas, all the other 360 antennas, all these circular antennas which you can see are all 360 in number, 360 antennas. Now each antenna is placed equidistant from each other in such a way that we form a perfect circle, and in that circle we'll have 360 antennas, right? And now you will see that the installation is a room. This is the room, and on top of this there are the whole structure is there, a concave shaped structure. On that structure these antennas placed, and this is the whole construction. Now we calibrated first, found out the magnetic north, 360 antennas, all right. Now all this arrangement and all these antennas are connected to certain equipment, the VOR transmitter equipment in this room. It is enclosed. This is unmanned room. Only from time to time we can only, go and do the maintenance part here. Nobody is manning this. Nobody is staying in this room. They are all automated. They run by themselves. No manual running is required in this. Okay. Once the system starts, it keeps on running 24 hours non-stop till some fault comes. Once some fault comes, somebody will just have to go and rectify the whole thing. Fine. Now, when I go to again, I will go to that diagram again, and we will see this 360 direction. On top, we had that vertical antenna, and all these 360 are those antennas. So you can say you are having 010 means there are 10 antennas between 010 and this is 000. This is 000. Magnetic north is having two values, 000 and 360 also. Why? Because it finished 350, 351, 352, 353, 352, so on up to 359, 360. So magnetic north has two values. It starts from 000 and it is end at 360. This I told you before also, I remember. Anyway, so you are having one antenna which is pointing upwards, magnetic north, slightly inclined, and all these antennas, 360 antennas, placed at 1 degree each. I cannot draw 360 antennas here, not difficult. That's why we have placed this at 10 degrees interval. But that doesn't mean there are each antenna is at 10 degrees. Each antenna is at 1 degree. That means between this 360 and between 10, there are 10 such antennas. 001, 002, 003, 00, so on up to 010, 011, and that way same way 360 antennas are there. Now actually we come back to our original diagram of the VOR station. In the VOR station, these 360 calibrations are done, and once the VOR transmission starts, now the VOR I told you the frequency allocation is from 108 to 117.975. Okay, on even and odd decimal placing along with ILS. So whatever frequency allotted to your VOR station, on that frequency, out of that 108 to 117 decimal, the the WPC, of course, the WPC looks after the frequency allocation in India. It will allot one frequency. On that frequency, you will start your transmission of this VOR. Suppose you started the transmission of this Mumbai VOR. Suppose this Mumbai VOR, you started transmission. When the transmission starts, what happens? One signal will leave from this antenna, which is pointing towards magnetic north. The signal will start going out of, when the transmission starts, the signal will start going out of this antenna, vertical antenna, pointing towards the magnetic north. This signal, which is going out of this vertical antenna, which is pointing towards the magnetic north, the rate of transmission is 30 times in 1 second. In 1 second, 30 times. It's very fast, very fast. Just you cannot even speak out your name once in 1 second. The whole name, if you go to speak your own name, it takes more than 1 second, I think, normally. So, but the signal is so fast that towards magnetic north, it will start the transmission, and it will transmit one signal which will leave out of this antenna and travel towards the magnetic north. Whose magnetic north? Magnetic north of this VOR. It will travel only in that direction because this antenna is pointing only in that direction, and we are passing. It is directional. It is directional signal. It will go only through the magnetic north and towards the magnetic north of that VOR. And the rate of transmission, the speed at which we are doing this transmission, is 30 times 30 times in 1 second. In 1 second, 30 times the signal will leave. Very interesting. This signal, which leaves the VOR antenna pointing towards the magnetic north 30 times a second is called reference phase signal. Whatever I am telling you just now, all the things are given in your notes on page number 36. When you find just now, when I refer to the frequency part of each and everything what I'm telling you is written there. That is for your reference. But I'm trying to explain to you in my own words and trying to make it very easy for you to understand, because if you go by the book and follow by the book for the first time, you will find it difficult. When I tell you something and you have a background of your own, then you read it from the book, you will follow the book more easier. So I'm trying to explain this working of VOR in my own language and trying to make it simple, trying my best. Okay. So 30 times the second is the signal which leaves the magnetic north antenna of the VOR. This is known as reference phase signal. Reference word, REFER, reference phase signal. This is known as reference phase signal, transmitted at the rate of 30 times the signal per second. That is the speed of the signal. 1 second, 30 times it will leave from here, 30 times. So you will agree to me, it's very logical. When one signal is leaving 30 times a second in the direction of this magnetic north, don't you feel or don't you agree that continuity of magnetic north is established? Continuously you will get a magnetic north. Which magnetic north? Magnetic north of this VOR. Because the spacing between two signals is negligible. 30 times a second means continuously you will feel that there is a signal going towards magnetic north or ascertaining the magnet. So you got a permanent magnetic north of the VOR facing towards the magnetic north permanently. Why permanently? Because there is no space between two signals. 30 times a second means hardly there is space in that continuity, in continuity 30 times a second. So constantly you will get a beam pointing towards the magnetic north of the VOR. So magnetic north of the VOR is ascertained with the help of radio signals, right? Similarly, what we do at the same time, all these antennas, 360 antennas placed at 1 degree each from the magnetic north, 001, 002, 004, 005, so on up to 090, then 180, then 270, 271, so on up to 360. All right. At the same time, when the reference signal is transmitting 30 times a second, at the same time, one more signal will be transmitted, which will not leave from the reference phase signal, but rather from the first antenna of this antenna, circular antenna, which we have fixed 360 antennas. One signal will leave from the antenna which is 360 in number. First one is where it is in line with the magnetic north. That also is at 00. Magnetic north also was at 00. And this also is inclined with the magnetic north at 00. Reference is from 000 degrees. Then you start the count. 001, 002, 0. But the reference is always 0. So one of the antennas is in line with the magnetic north antenna. So the first signal which will leave from this, which is at 00. It will leave from 00, but it will not stay put in 00. What it will do? It will actually be, immediately from that, it will leave from this magnetic north, that circular antenna 000, it will leave, and we actually, that is, a rotatable signal. That signal is not transmitting in one direction. It is a rotating signal. This second signal which we produce is having a tendency to rotate clockwise. It will start its transmission from magnetic north, rotate and go to 001, 002 antenna, 003 antenna, 004 antenna. Actually, it will travel through all the 360 antennas, keep on traveling through all 360 antennas, energize all the 360 antennas and come back to the magnetic north. All right, it will cover this entire circle of 360 directions. One after another, it will enter the antenna, one after another, all 360 antennas, and come back to the original 000 antenna. Okay, one complete circle it will complete. That rate of transmission also is 30 times a second. Now, this rotating signal which leaves the 000 antenna and goes to 360 degrees and come back to this 000, 30 times a second is known as variable phase signal. It is known as variable phase signal. Now we produce two types of signal. One transmitting continuously towards the magnetic north at 30 times a second. That was the reference phase signal. Another signal which we produced also was transmitting from the magnetic north, but not staying in magnetic north. It turned clockwise, went to 001, 002. It started rotating and covered all 360 directions. And that transmission also took place 30 times a Second, that is known as the variable phase. Variable because the phase is varying. It is not constant. This was constant. Reference phase signal is constant. It is showing you only one magnetic north direction. The other one which is rotating is not showing at 1, then goes to 002, then goes to 003, then goes to 004. Covers all the threes. That will not leave a single antenna. One by one clockwise in the chronological order. It will go through all 360 antennas, come here, and again same process. The continuous circular transmission takes place and continuous magnetic north transmission takes place. So now we have two types. One signal is pointing towards magnetic north 30 times a second. Another is rotating to 360. Now this has a range. Magnetic north reference phase signal and variable phase has a range. Sometimes the range may go up to 150 nautical miles. So this signal which is rotating is actually rotating in 150 nautical miles and coming back. 150 nautical miles and coming back. The same way, magnetic north, you can get this magnetic north not up to 150 nautical miles. Up to 150 nautical miles. This was the range of the VOR. This range can be increased or decreased as per our power of transmission. We can increase or decrease our power of transmission for the range required. But normally, VOR can sometimes high power. VOR actually basically divided into three categories: low power VOR stations, medium power VOR stations, and high powered VOR stations. Actually, low power VOR stations are not used for navigation because they are radial. They are this 360 hands. See, antennas will finish somewhere here only. But after the antenna, it's coming out of the antenna going up to 150 nautical miles. So you can say that each hand is 150 nautical miles long of all the 360 directions. We are having 360 hands going outward from the center of the VOR and out from the antenna and extending out in a range of 150 nautical miles. 360 hands. So these 360 hands of the VOR are otherwise known as radial. Otherwise known as radial. Suppose one radial. Consider radial 090. Suppose this is one hand which is transmitting 090 up to 150 nautical miles 090. Okay. Now suppose one aircraft wants to go out of Mumbai. It will take the 090, go keep on following 090, 090, 090. This will take it outside Mumbai. Any one hand of Mumbai it will catch. It will go out of Mumbai, catch that hand and go. That is outbound radial up to 150 nautical miles. Conversely, or just opposite of that, suppose you are coming into Mumbai from anywhere outside 150 nautical miles, you can catch one hand of Mumbai which is extending out, catch it and come. Suppose I am here, I catch the hand of Mumbai, say 110. I catch the hand of Mumbai 110. I took the radial of 110, but this is not 110 actually. This is 110 was to go out. 110 was to go out. What will be the opposite radial of this? Now 110 is less than 180. So you add 180, you will get the opposite. When you add 180, it is 290. So just opposite to 110, you will see it is radial 290. So when you are coming to radial 290, you are coming into Mumbai like this. Okay. So you can come into Mumbai by 360 hands and you can leave Mumbai by these 360 hands. This is used for navigation purpose. We stay on the radial and go out of the station or come back in the station. So what you must remember from the VOR station is VOR offers 360 radials. That is, it offers 360 courses or radials outbound from the place where it is situated or in the range. If you are in the range, it may offer you one hand which is closest to you. It depends on your direction. Suppose my heading, if I'm coming from somewhere, say my heading in the compass is now 075 degrees. Suppose my heading is 075. I'm coming from somewhere 075 degrees. When I come in the range of Mumbai VOR, I come in the range of Mumbai VOR I'm getting on my set, and I'm in the range of Mumbai VOR. So which radial I will take, which will take me the closest to Mumbai? My heading is 075. So as per my heading, I will choose a radial 075. So between 70 and 80, one radial is there, 71, 72, 73, 75. So I will take the radial 075. When I catch the hand of radial 075, straight it will bring me to Mumbai. Okay. So this is the inbound radial to Mumbai. And similarly, to go out of Mumbai, I can take the outbound. Like I was discussing the charts and telling you, you take one outbound of one place. So that was that one outbound. And another VOR somewhere next also is transmitting, and that also is offering 360 hands. So outbound of this will point towards one inbound of that. Okay. So one outbound of this and another inbound of that will make the continuity of navigation, and you can take your flight from one place to another very safely, maintaining the continuity of navigation. Now, actually, when I was discussing this, the construction of VOR station, when I was telling you about the VOR station, see, when you notice this view, actually, when you look at this diagram, it will look as if these antennas are straight. These are not straight. Actually, they are slightly inclined in the sky, pointing to one direction, 001, 002. They are very slightly inclined. That means, actually, when the transmission starts, if they are inclined, like an umbrella, inverted umbrella. At home, if you have an umbrella, when you invert it, what happens? The umbrella becomes concave shape, right? In the umbrella, if you see the spikes, that aluminum spikes, where you see they are bent and they are pointing upwards like this, a concave shape. This also is concave shape. So what will happen when the transmission starts? The transmission will leave these antennas, and the general pattern which will be formed, will be something like a cone shaped transmission. It will be like a cone shaped transmission. Okay, see, like this, something like this. This was the central. This was the central antenna. Now, because these antennas are inclined, slightly inclined, not suppose the antenna was straight, then the transmission would have gone straight. But they are slightly inclined upwards in the sky, slightly inclined. That's why the signals will leave and go up in the sky like this, and they'll form the shape of a cone, like a cone. See, this is the cone. Just now I'm not doing this cone. I'm just telling you the transmission of a VOR is like a cone, cone-shaped transmission. Why? Because the antennas are slightly inclined. If the antennas were straight, then the signal would have gone straight, very straight in the air, up in the sky. We would have not got any range. Because of this cone, we are getting a range. See, we are getting a range, the coverage, because the antennas are slightly inclined. Even if suppose this antenna was straight, then the signals would have gone straight here, not in the air. We want the signals to go in the air, because the aircrafts, when they are flying at high altitudes, they must get the signals. Na? So that's why the inclination of these antennas are done, so that signals go in the air. Right. Now, what I want to tell you, very important thing, when we see one more diagram, specifically one more diagram, things will become more clear. Look at this. Now, this was the VOR station, all 360 calibrations, and this was the VOR. This was the magnetic north of the VOR, and this is 090, 180, 270, and in between all the calibrations are there, 001, 002, and all that. Okay. Now you see one aircraft is going towards the VOR station. It has taken some radial. It has taken some radial. So the inbound radial for this is radial inbound will be 330. Why 330? Why 330? See, outbound is 150. Outbound is 150. Outbound. This is outbound is 150. 90, then 100. This is 180. 180. So this is 130. Radial 130. Outbound will be, it is going through radial 130. Same aircraft just to come back 130 plus 180. 130 plus 180, that is 330. Okay, so inbound will be 330, because although it is pointing to, you will feel it is 150. 150 was to go out, but when you want to come back, actually you are following 350. When you come to 350, now exactly what happened when you said your radial was outbound 150, what actually happened? The magnetic north transmission was taking place, continues up to the magnetic north. It was leaving, it was going towards the magnetic north. Then all 360 antennas were energized, right? We just now told all the 360 antennas were energized. So your aircraft, actually, magnetic north is not rotating. It is fixed. It is going in magnetic north direction. But the rotating signal, one of the rotating signal has come and hit your aircraft. That is received in the receiver of your aircraft. So the angle, that signal is that angle, this angle, actually this angle, whole angle is how much? 150. This angle is 150. That's why it is actually measuring the phase between two reference. We have the reference phase signal and the variable phase signal. So what the VOR is doing, actually, VOR is measuring the phase difference between the reference and variable. Reference is how much? 000. Variable is how much? It will measure the variable angle. At what angle you hit the aircraft? This angle. This angle from where? This angle from the reference. This angle was at 00. From 00, 10, 20, 30, 40, 50, 60, 70, 100, 110, 20, 150. So it found that the angle at which it met you was 150. 150. So the radial displayed will be 150. You have taken radial 150. Similarly, when you are coming back, now see the reference phase signal is this. Now the angle which it measures will be the entire angle up to here. Entire angle up to here. Entire up to angle here will be 330, will be 330. How 330 from where? From the reference phase signal. Reference phase is constant 0, 0, 0. And what radial you are following? 330. So the angle between the radial you are following and the reference phase signal is how much? 330 degrees. 330 degrees. So in other words, we say VOR compares the phase difference between whom? The reference phase signal and the variable phase signal. Reference phase signal, which is fixed at 0, 0, 0, and variable signal, whatever variable signal hits you at whatever angle, because one of the radials will follow out of 360, any one radial will follow. Suppose you are coming from somewhere here, you are following radial, say 270, but 270 from where? 270 from the reference phase. The entire angle, this angle will be 270. So it is measuring the angle between the reference and the variable phase signal which has hit you, or rather which is received by your aircraft in the VOR. You can say hit you is not a correct language, which is rather received in your VOR receiver. The difference between both the phases is compared, the angle difference between both the phases are compared and displayed as a radial in your radial display in the VOR, that is in the cockpit. The radial will be displayed. It will measure the phase difference and convert it into a radial and display the radial angle. All right. So you will know now. I will come to one more very important thing. This was we talked about the whole scene which is outside, in the VOR station. What happens in the VOR station outside? But we must also know in the aircraft what do we have? In the aircraft we'll have a dial like this, something like this. In the aircraft we'll have something like this. You will see a pointer like this. This is also known as a cross pointer. This is known as a cross pointer, or otherwise in VOR receiver, the VOR receiver is attached to one of these dials in the cockpit. It is there in the cockpit. It is, you can see it is written here, OBS, Omni Bearing Selector. O for Omni, B for Bearing, S for Selector, Omni Bearing Selector. Actually, when you look at this Omni Bearing Selector, it's one thing is very, very peculiar in this Omni Bearing Selector. Actually, the card, this is the compass card. This is known as the compass card. This is not the compass card. You will see in this compass card, it is now at a very erratic value. It is not set at 0. The 0 is here. This is 0, is 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, again 360. 330, 340, 350, 360 or 00 are the same values. 360 will finish here and 00 will start here. Actually, how it has come here? Because the Omni Bearing Selector is a rotatable knob. Like in the altimeter, I also told you, there is a rotatable knob at the left. Similarly, in Omni Bearing Selector also there is a rotatable knob. This knob can be rotated clockwise or anti-clockwise. When you rotate with your hand on the clockwise direction, this entire card can move. This entire card will circular. This is a circular card which can move to the right or to the left as per your operation of the Omni Bearing Selector. If you move the Omni Bearing Selector to the left anti-clockwise, the card will move anti-clockwise. If you move it to the right clockwise, then it will move clockwise. Whatever, whenever you select a radial, suppose you are asking the ground, give me a radial to reach you, or look at your heading and decide the radial. Suppose my heading is saying, my heading is saying, suppose 240 or 250, suppose radial 250. What I'll do, I'll keep on rotating this card. I'll keep on till the needle. This needle will not go here and there. This needle will be constant. Okay, this is the reference needle. This reference needle, vertical needle will remain constant. Only this card can rotate. When you rotate the card, you bring the desired value radial reading to the index of this, needle. Okay, to the index of this needle. When you bring it to the index of this needle, you will see that now you are following 250 radial. Suppose you are following 250 radial. Fine. When you are following 250 radial, keep on following 250 radial. Okay, you will reach the VOR station. But for some reason, if you are really not following 250, then it will still show 250. I mean, what you selected once on the compass, the card, this compass card will not rotate by itself left or right. Okay, unless you adjusted by the Omni Bearing Selector. You selected Omni Bearing Selector. Why we call it Omni Bearing Selector? Omni means multi-directional, all 360 direction. Bearing Selector. You select the bearing of the VOR. See, VOR station is giving its direction with reference to itself. That's why it is known as a bearing. It is not giving you a heading. It is the direction which you will take to reach it. Okay, what direction it is? Okay, now kindly rejoin. एक डायग्राम गायब हो गया है अपनी।